All right, here we are in C++ functions, and functions are great because they allow for a lot of flexibility and modularity in your programming. So whatever application that you're writing, you're going to have functions, and really the functions are going to turn into methods when we start making classes and objects. But let's just understand functions and what they're all about and how they look and what the syntax is. And this topic is going to be more heavy on coding examples. We only have like 8 slides. So let's just get to it. So what's a function in C++? And function in any language, it's just a small block of code that does a specific task. So when you're developing functions, your program is going to have things that it needs to do, right? So you're going to write an application that does something specific. During those specific times that it's doing its job, you can write small little modular programs that perform an operation for you. And then you use that function throughout your whole application. We have a term called encapsulation, and that just means that we're just kind of taking our code and putting it all into one space. We're encapsulating the code. And modularization means that if you write a really good function, there's no reason why it might not be applicable in other applications. Or you can use that function multiple times throughout your decision-making process as your application runs. So that's that. So let's get to our syntax. Syntax, just like declaring variables, right? We know that there's a syntax to declaring variables. We have to have a variable type. What is the data type? What is the variable name? And then we should assign it some value according to the data type. A function has these rules when setting it up. It has to have a return type. Now, I'm going to talk about functions a little bit after this, but one second. So this is my return type. This function is going to give back an integer. I'd like to call it a fruitful function. It gives back something. So this function is going to and must return an integer. The name of my function is my funct. So the function should have a return type, and we'll talk about the return types in the next few slides. This one returns an integer. It's called my function. I have a parameter, and this is a parameter, and I'm going to pass in an integer. See, I'm just making a variable right here. Our parameters that we passed in, some people will call them arguments. That's going to be up to your instructor. But these right here, you can call parameters or arguments. These are data type. These are variables. So you're declaring a variable, right? So this parameter, we're going to use this parameter inside of the function. Notice my bracket. Now I have the body of my function. This is my function body. Body, not my function body. We have the type, name, our parameters, and this can be empty. We'll see that. And then your function body. What does this do? Well, it takes an integer, it times 2, and then it returns the integer. See return? Return is going to meet this. Now, let's talk about this really quick. Return and parameters. You can have, this can only return one thing. Okay, let's say a function is a castle, right? A kingdom. Function is a kingdom, and everybody's welcome in the kingdom, right? So then you go into the castle, and the castle says everybody can come into the castle yard, and those are your parameters. So here are the castle doors, and you can have like 200 or something arguments. If you have a function with 200 arguments, you rethink that. But you can have like 200 arguments, but then you can only return one thing. So while you're inside, after you've gone through the gates, and you're here in the body, you need a guard to get you out of the castle. And the guard can only take one data type at a time. So this guard's name is return. And you say, guard, I need to leave. And it says, okay, are you an integer? And you're like, yes, I'm an integer. And it says, all right, let's go. I'll show you how to get out of here, but only you, nobody else. Okay? And we'll get into collections later, so how we can return multiple things. But right now, we're just returning one thing. So this is the syntax. Return type, name, parameters, body. Okay? In order for us to use this function, we have to call it. Okay, and when we call it, well, I'll show you that during examples, we're just going to call it by name, right? So if your function was like Leo, you would just call it, and then your function would run. So We've named it, we can call it. So function parameters or arguments, there's different types of parameters. The ones that we're talking right now is called pass by value. And this just means we are declaring variables. So when we pass into this function, we're going to pass by value because we're going to create brand new variables. We're going to create an integer variable and a string variable. And then this is just going to print hello, whatever we pass in. And then it's just going to return the param. Okay? Because it can't return a string because it has to return an integer. Data type has to match. This is passed by value because we're creating brand new variables. Later, when we get to pass by reference, when we start talking about value and reference, reference means we are not passing by value, we're getting the address. So C++ allows us to just go ahead and go right to the address of the data type. But right now, don't concern yourself with that. Just concern yourself with writing good parameters, declaring a variable, and giving it a name. Okay? So just worry about syntax. Like I said earlier, functions can return any data type or no data at all. Let's say you write a function and you don't want it to give back any data. You just want it to do its job. Well, that would be a void function. So you have to declare what it's going to return, and if your function is not going to return anything, it's just void. Right? Void. Into the nether. So this function, just doing stuff, does one thing. It just prints nothing. And then it's done. You can return an integer as we saw earlier. Now there's the guard. Hello guard. Return, come bring this integer out of my castle. And then return will bring the integer out. You can return strings, right? And that would return Leo the dog. You can return doubles, and that would return double. You can return floats. You can return other objects. So you can pretty much return any data type. In fact, you can return any data type. If you create an object, a dog object or dog class, and you want to return a dog, you can return the dog. But what I want us to focus on is just understanding our data types, because we did such a good job during data types and variables, and know that we can return any of the data types that we use. So your function will always be able to give back information that you can use in another part of your program. And that's what function's good at. Now, function prototypes, C++ uses function prototypes. We'll look at a function prototype. These really come more into play when we develop classes, but it's part of understanding functions. A function prototype, we'd have these in our H file all over the place. So our function prototype, same thing. There's our data type. There's our name. Here's our parameters. This one has 3 parameters. And notice it ends with a semicolon. So the prototype is just a statement. And what that does is that allows you to look over your functions and allows you for a little bit more encapsulation. Look over your function and say, okay, I know the name of my function, I know what it returns, and these are the parameters that I'm going to have in it, and later on I'll write it. All right? So I'll show you what these look like. You won't get into these until we start getting more into classes. But some people, some old school people have these, and I'll explain when we go to start writing code. It's better if I explain it with a little better example. But you might see these when you're doing research for one of your projects. You can overload a function. Okay, again, this returns nothing, right? Here's the same name overloaded. But what's different? This is called these parameters. There's 2 parameters here, 1 and 2, and there's 3 parameters here. So because it has the same name, we can just go into our main, or wherever we're going to call this function, and we can say overloaded 3, 4. And then that will find the overloaded function name with only 2 parameters. And then I can say overloaded 3, 4, 5. And that's going to find the function with 3 parameters. So you can have the exact same name, you just have to change what we call a signature, or change the parameters. And then you can use the same name. Overloaded functions, it starts getting into this area where we get into it with polymorphism and stuff. But it's just good to know about. Sometimes you're going to write and you'll actually name a function twice and it'll get confusing and you'll look back and go, oh, I know now. Just comes with practice, practice, practice. Recursion is another function. And for me, recursion is a loop, right? A recursive function is a function that just calls itself. So data type, function name, parameter. See this? I'm calling the function x minus 1. So what happens is this function will keep going and calling itself, and it goes in, it just gets to the back here and it comes back into this, calls the function back. And if you don't have a return or what's called a base case, and my base case is when x gets to 0. If x gets to 0, so let's say I pass in 4, it prints out 4. X is 4 is not 0, so then it sends back a 3, and then it prints out 3, and then 3 is not 0. This is just like a loop. We've initialized, right? So here's our initialization. Here is do until we get to it. And here is our incrementals on how we get to that spot. So we can use functions like we do loops, and recursive functions are a lot of fun. I absolutely love recursive functions. And that's going to be it. So now we're going to jump over to the compiler and we'll get ourselves started and we'll start looking at some functions that I wrote for us. All right, everybody. Here we are, recording, having a good time, doing that sort of stuff. But what I want you to look at is here's our main, right? Oh, make sure your Solution Explorer is open. Here's our main. So this, remember the main function in the main method, it's also a function, right? Return type, it returns an integer. There's the name, and it has no parameters passed in. We were writing loops and things like conditional statements inside the main. We're going to start writing functions. Because the main is a function itself, you cannot write functions inside of the main. So we are going to write our functions outside of the main. And we're going to talk about our very, very first one, and that's going to be our void function with no return. So this is a function that doesn't return anything because it's void. And notice that I'm following the things. I have a return type, void, a function name, then I have my parentheses, and I'm not passing any value to it. A bracket, and then I have a small little program. And my program is going to initialize a variable called bones, and to give it 10, and initialize a variable called name and give it Leo, and then it's going to print out Leo can eat 10 bones. Okay? Now, all this happens inside the function. Once this function is over, this bones and name, those are not accessible outside the function because of what we called scope, right? We talked about scope with our variables. So these variables and values die as soon as the function is over, and that's why we like return statements. So let's take a look at what happens. I'm just going to call it. See, I'm in the main, and what do? I say no return. That's the name of the function. There's no parameters to be passed in, so I'm just going to run return. And then no return, what it'll do is the main will say, hey, I got to go find this small program called no return. It's got to be here somewhere because I didn't throw a linker issue when I wrote it. And there you go, Leo can eat 10 bones. That didn't turn anything. Everything that we did was inside the function. Now I don't have to comment these out, I can only comment my calls out, right? So now I have a function that returns an integer. If I run this, it's going to return the integer, right? So it's integer return. And it's making a loop for I is 0, I is less than the first number, so we determine how many times our loop runs. The second number is going to add 5 to it each time it does, and then it's going to return the second number. But here's something about returning. If you have a function that gives value back, you need to do something with it. So you can declare a variable, this returns an integer, and it can equal that because it'll return an integer into the x, right? And then you can use x sum later in your program if you want. So like we can see out. We can see out x, And now we're going to see what, if I pass in a 10 and add 5, I'm going to run the loop in times, and 5 increment by 5 each time, and then return that value out. And we'll see what number we get. So it passed in a 10 and then a 5. And then it's going to run. And when it gets done running, it is 55. So I calculated a number called second num, and I returned that value second num, and I returned it into a variable I created called x, and then I printed it out. Now we have a string, right? We're doing the same thing because it returns this string return. This returns a string. And we're stored into full name. It's going to come up here to string, and it's going to say take the first name and return the first name plus a space plus the last name. Whenever we take two strings together, that's called, we're going to concatenate our strings. So when we add strings, we concatenate them. This is just going to return Mike Sarlo. So I have two variables, and now I'm going to store those two variables into one variable called full name. And we'll talk about user input in a bit, because programs that don't have user input are boring to me. See, just passed out full name. So we took first name and last name, and we added them together with space between it and created a new variable that this function's job was to concatenate a full name from a first and last name. So we got that going for us. Now, here we're going to declare a variable called integer, right? So we declared a variable called integer, and then, oh, this is my pass value passed by reference. I might be a little bit too fast on that. Is that foo? Yeah. We're going to come back to that. Let's do our inline function. That's my favorite. Pass by value reference is my favorite. Okay, inline function. See where it is? Inline function is going to return some doubles. It's going to return, inline function returns a double. Double first param, second param. Notice I declared it up here. Now I have to go down underneath and I have to write it. So here's my inline function with out of scope resolution operator because it's in the same file. You're not going to use inline functions that often, but you'll get the terminology because that's what books do. So here's my function. And here's me completing my inline function. Here's me calling my inline function. Notice I return a double, so I'm just going to print it right away. I'm not going to make a new variable. I'm just going to print it right away. And that will be, and then it'll just give me what value ever I had. I'd first divided by that, 6.3. See, it's a double. If that was an integer, it would return the 6 by integer division. Don't do that. Okay, so that's my inline function. Now we're going to do our recursive function. Our recursive function is what I like to call a loop, because it really is. But my recursive function is right here. Recursive function, see the name of it? Recur. I'm going to pass in an integer. It's going to print the integer out. Then it's going to check for 0. When it's not 0, it's just going to pass back that integer minus 1. And it's going to keep doing that. If I don't have a base case, if you guys don't have a base case, you're going to get what's called stack overflow, because a function runs itself on the stack, and you'll get to that with a little more experience. But that's how you get stack overflow if you have a recursive function that doesn't have a base case. My base case is the minute x gets to 0, it's going to return 0 and stop the function because it's not returning anything. But notice this returns an integer, so I can have return integer. I'm just going to call with a 10, and you can guess what this is going to print, right? It's going to print 10 first, and then 10 minus 1, 9, 8, 7, 6, 5, 4. This will actually print 2 zeros, but that's all right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just like a loop, right? So that's my recursive function. Okay. Now, one more thing, because we discussed it. It's called pass by value and pass by reference. Here's a function called foo. And in my function called foo, or it's passed by reference, I have a variable called foo. Never mind. A variable called foo. This is going to pass by reference. First, we're just going to pass by value. Now, when I say pass by value, I'm going to create a brand new variable. All right? So down here, I have, what are you angry at? Yeah, it does. There you go. Right here, see this? Foo equals 55. And remember what I said about scope? Well, let's look at this right here. I create a variable called foo, and it has a value of 10. So when I print this, it's going to print 10. And then it's going to print 55. And then it's going to print 10, because this 55 goes away. Right? Because it created a brand new variable. We'll just call it foo2. And we'll call this foo2. Okay. So now foo2, but it didn't change this initial foo. This foo stayed the same, right? I passed foo in, but when I passed foo in, I created a brand new integer, and it's 10 before call and 10 after call. Let's look at that again. What's happening inside the function? Notice this is a void function. This doesn't return anything. Okay? So now when I run it, and this is passed by value, because I'm creating a brand new value with this, like I'm declaring a variable, right? It's fat. Come on. Come on, you're wasting everybody's time. I got a full build. Right there. There she goes. Holy cow. Too many resources. 10 before call, 55 inside the function, and 10 after the call. See that? So this foo is unchanged, right? But what if we pass by reference? If I put an ampersand here, right, I'm going to pass by reference. So here, I'm just going to say, we're going to pass the reference of foo, all right? And then we're going to make foo equal to 55. Let's take a look at this. Now what we're doing is we're passing the address. Notice it's void. So I'm not returning anything. Now we're not going to spend too much time on this rabbit hole because it's to it when we get to it. But look, what happened? 10 before the call. It's inside the function. And now foo has changed to 55. And how did we do that? Well, we added a reference. So what we did was we went to foo's memory location. And we said, hey, I'm just going to go ahead and change you to 55. And because we are at the actual memory location of foo, we could go into that and we could change the value of that integer. And that's pretty cool. More on this when we get to our arrays and our vectors, but we need to know pass by value and pass by reference. Remember, functions, return type, name, parameters. Return type, name, parameters, bracket, body, bracket. When you want to use a function, you call the function. If you don't want to use the function, don't call the function. Okay? All right, that's it for functions. We're really close to start putting together a small application, our first kind of program. Practice writing some functions. Just go ahead, pause, and write these functions out, and then come back and run them in the main. At least do that. Get a feel for them. Okay, you guys are great. I'll see you as soon as I can with our next installment. Talk to you soon. Bye.